Hi, 7th grade. Welcome to lesson 8.8, solve problems involving surface area. By the end of the lesson, I want you to be able to say, I can find the area and surface area of two-dimensional composite shapes and three-dimensional prisms. Let's solve and discuss it. Alea will paint the outside of a box with 3 different colors. Decide how she could paint the box. What is the total area that each color will cover? So there's multiple different options. We could paint the top green and the bottom green. We could paint the front red and the back red, and then maybe paint the sides purple. Then it says, what is the total area each color will cover? Well, let's talk about the green first. That was a rectangle, and it's 16 by 32. Remembering that area is length times width, so we get out our calculators and do 16 times 32, and that's 512 inches squared. But remembering there's 2 of them, there's the top and the bottom, even though we can't see it. So we multiply that by 2, and that gives us 1,024 inches squared. Next, we can do the red face. So that was like the front and the back. And that face is still a rectangle, but it's 14 by 32. So same process, 14 times 32. It gives us 448, but there's 2, the front and the back. So that gives us 896 inches squared. And last but not least, the purple sides are rectangles, but they are 16 by 14. So length times width gives us 224, but there's 2 of them, so we multiply that by 2 to get 448 inches squared. Focus on math practices. Trista paints each pair of opposite sides of the box with the same color. How many different areas does she need to find to determine the total area covered by each color? Well, it's exactly what we just did. So she needs to find 3 different areas for the 3 different colors. She only needs to find 3 because she just multiplies them by 2 because there's 2 of each. Example number 1. Find the area of composite figures. A city planner wants all neighborhood parks to have more green space than non-green space. Does this park meet the requirements? Explain. So we need to figure out, is there more green than there is not green? The shape of the non-green space is a composite figure. A composite figure is the combination of 2 or more geometric shapes. So they divide the park into familiar shapes, using the information given to find the dimensions. So we can see that they cut it up. But they also tell us, okay, if this is 12 and the whole thing is 24, so then they add the areas of the non-green shapes. Add the areas of the non-green shapes. So they found the area of each of these. They did the A part with 14 times 24, B part with 11 times 24, and C is a triangle. Remember, the area of a triangle is 1/2 base times height. So 1/2, 24 times 24. Then they found the area of the entire park. So the entire park is 49 times 36. Then they subtract the area of the non-green part. The non-green part, they added all the 3 together to get the whole amount that's non-green, and they get 876. So 876 feet squared is how much is green. 888 feet squared is how much is non-green. It does not meet the requirements since the non-green area is greater than the green area. Let's try it. This diagram shows the area of a room to be carpeted. What will the area of the new carpet be? So they broke it up into 2 shapes for us. A, which is a rectangle. Oh, not that. And B, which is a triangle. So first they want us to find the area of A. That would just be length times width. 5 times 6, which is 30 square feet. Then they want us to find the area of B, but we need length and width, or height and base. The height is still 6. This whole thing is 9. All the way across is 9, but that's not our base. Our base is 9, take away this 5. So 9 minus 5 equals 4. So our base is 4. So B is 1/2 6 times 4. 6 times 4 is 24, and half of that is 12. So then we add that together, 30 plus 12, to give us 42. The area of the new carpet is 42 square feet. How does knowing the area of familiar shapes help to find the total area of a composite shape? You can find the area of those and add them together. Okay, example number 2. Solve surface area problems. Gavin constructed a model building and wants to cover the outside with paper. How much paper will he need to cover the entire model? First, we need to find the area of each face of the model. So what they do is laid it out flat for us. The blue parts here cover the roof. So that's this part and the one off the back. That's why it's 10 centimeters by the length of 24. The green parts cover the sides and the bottom of the building. And then the orange part covers the side and what leads up to the roof right here. So you can see them break it down for us and see every part. So then we are going to find the total surface area. So let's do the blue. That's 10 by 24, and there's 2 of them. So 10 times 24 gives us 240. That's why they have 240 times 2. Then the green part is 12 times 24, which is 288. They multiplied by 3 because there's 3 of them. Then the last step they did, they broke it off into a square and a triangle. The square is 12 by 12, which gave us 144 times 2 because there were 2 of them. And then the triangle, well, if the square was 12, this must mean this is 8. So it is 12 times 8, but 1/2 of that. 12 times 8 is 96. Divided by 2 is 48. And there's 2 of them. Multiplying first, and then we add, just like PEMDAS. Solve mathematical problems involving surface area. What is the surface area of the composite figure drawn? So find the surface area at the bottom of the composite figure. So each square face is 6 by 6, and 1 square face is not included. So 6 times 6 is 36, and there are 5 of them. Find the surface area at the top of the composite figure. I think they're missing that in their drawing. Oh no, I see it now. It's it's got a pyramid on the top. So it's filled with 4 triangles. Area equals 1/2 base times height. And there's 4 of them. Then we add them together. Let's try it. Hiromi is painting the front and back of a barn. Each can of paint covers 32 square feet. How many cans of paint does Hiromi need to cover the entire front and back of the barn? So he just wants the front and the back. The front and the back is a shape like this. So let's break that shape down. I see a rectangle and a triangle. So this height is 11, this height is 12, and the whole thing is 15. If the whole thing is 15 and from here to here is 11, we can do 15 minus 11, which is 4, to find the height of the triangle. So now we find the area of the rectangle, which is length times width, which is 11 times 12, which is 132 feet squared. Then we find the area of the triangle, which is area equals 1/2 base times height, which is area equals 1/2. The base is still 12, and the height is 4. So 12 times 4 is 48. Half of that is 24 feet squared. So then I add them together, 132 plus 24 gives me 156, but that's just one side. There's 2 of them, the front and the back. So I multiply that by 2, and I get, I think that's 312. 6 times 2 is 12, carry the 1. 5 times 2 is 10, carry the 1. Plus 1 is 11. Yes, okay. 312 feet squared. Sweet. Key concept. The area of a 2-dimensional composite figure is the sum, remember sum means add, of the areas of all the shapes that compose it. The surface area of a 3-dimensional composite figure is the sum of the areas of all of its faces. Let's say it. I can find the area and the surface area of 2-dimensional composite shapes and 3-dimensional prisms. Have a great day.